Hey everybody, it's Mr. Carr again. Today we're talking about 10-2 day 2, and that is talking about sequences in terms of what's called a series. When we're asked to find the sum of terms of a sequence, that's called a series. Okay, so this is the formula. So usually, in this case, what we're going to be dealing with is what's called the finite series. We talked about that in day 1. Remember, a finite series would be something like this: 3, 5, 7, 9. It's just those 4 numbers. Okay, this is a formula that's going to find the sum of those numbers right there. So if I use those for just a quick example, so if I do 3 plus 5 plus 7 plus 9, that's going to give me a total of 24. Okay, instead of doing that, like especially if we get to longer series, I don't need to take all 4 numbers and add them up. We look at the first term, a sub 1. We look at a sub n is the last one. So this case will be a sub 4. Okay, the formula is going to use this setup. N is the number of terms. A sub 1 is the first term. A sub n is the last term. We just plug these numbers in. So again, as a quick demonstration of how this works, if I say S of 4, these 4 terms, the sum is going to be 4 divided by 2 times the first term, 3 plus 9. Okay, so that means the sum here is going to be 4 divided by 2 is 2, 3 plus 9 is 12. Multiply those out, and I get, hey, look at that, 24. Okay, again, with a small sequence, pretty straightforward. You could easily do 3 plus 5 plus 7 plus 9. But as we go on to some of these other ones, so for example, this one, now we got some challenges going on. So we know the beginning and we know the ending, but we don't know the number of terms. So again, here's my formula. So S of n is equal to n over 2 times a sub 1 plus a sub n. Technically speaking, I know this number, but I don't know the number of terms. So we're going to use what we did in the last video. All right. Sorry, scroll down a little bit. So we're going to use what we did last video to find my a sub n and find the number of terms. Because what we know is we know the common difference. Plus 4 plus 4. We know the a sub n, we know where it ends up is at 80. That's my a sub n here. And this is my a sub 1. So I can set this up with my formula from before. N minus 1 times d. But now we're going to use this to solve for n. This will be the number of terms. So 80 is equal to 8 plus n minus 1 times 4. Okay, so instead of distributing out the 4, I'm going to start with subtracting 8 to both sides. So I get 72 is equal to, I'm just going to put this in front, 4 times n minus 1. Now I could divide both sides by 4 here. Okay, so I'll just do that real quick. 72 divided by 4 is going to give me 18 is equal to n minus 1. So then I add 1 to both sides and I get 19. What this establishes is that this is actually a sub 19. It's the 19th term in this sequence. So if I want the sum of all of these numbers, so it's these and this one and everything in between, that's what we're representing with the ellipses there. We're going to do this as the sum of the 19 terms is 19 over 2 times the first term plus the last term. Okay, so that'll be 19 over 2 times 88. So 88 times 19 over 2 is going to give me 836. Again, this is every single number added up, including the ones I did not write down. Okay, so that is our formula that we're going to use for today. We're going to use that in a variety of ways. So for example, find the first 3 terms of an arithmetic series in which a sub 1 is 14, a sub n is 29, and s sub n is 129. So again, think about what the formula is. We have n over 2 times a sub 1 plus a sub n. We know this, and this, but we don't know n. So multiple parts of this one. This is going to tell us n. Once I have n, I can use that to find my common difference. Okay, we don't know the common difference to tell me how do I change a sub 1 into a sub 2, a sub 3, a sub 4. So let's fill in our formula with what we have. We have 129 with an n over 2 times 14 plus 29. Okay, so we can do n over 2 times, we got 14, 14 plus 29 gives me 43. Okay. And then I don't want to deal with fractions, so I'm going to multiply both sides by 2 here. That'll get rid of that. So 129 times 2 is going to give me 258 equals 43n. And then divide both sides by 43. And I get 6 for n. So what that means is a sub n is 29. Really, a sub 6 is 29. Well, to help me find my common difference, I'm going to use my other formula for arithmetic sequences. The a sub n is equal to a sub 1 plus n minus 1 times d. Okay, so in this case, we're going to do a sub 6, which is 29, equals 14 plus my number of terms, 6 minus 1, times d. So we can subtract 14 over. Okay, so I get 15 is equal to 5d, divide by 5, and I get 3 for d. So find the first 3 terms of an arithmetic sequence in which a sub 1 is 14. Well, it says first 3 terms, so officially it's 14, add 3 for 17, add 3 for 20. Okay. So again, we're going to use that formula, combine it with the one we did before with the equation for any arithmetic sequence. What we're also doing with these series is we're representing this idea. In math, we use the Greek capital letter sigma, which looks like this symbol, as a shorthand way to represent our addition. Okay, lots of times we use sigma to say the sum. And so that's what's happening here in this case. If we look at this here, lots of times it's set up this way where n is a number above the sigma symbol, k equals 1 is representing underneath. So f of k is kind of the formula or whatever the rule is for our sequence of numbers. So in this case, if I look at this one, another way of saying this is I have an arithmetic sequence. I know it's arithmetic because this is actually a linear pattern, 4k plus 2. I'm starting it at the first term. I'm ending it at the 12th term. So kind of connecting this to what we do in our arithmetic sequences, we're looking at a sub 1 and turning it into a sub 12. Okay, that's what we're going through this pattern here. So again, what this is going to represent my a sub 1 here. If we plug that in, that's 4 times 1 is 4 plus 2 is 6. There's a sub 1. Okay, this is my a sub 2. That turns into 10. That's all it is. So with this sigma, we can actually use our formula of like for our sum of a series. We don't have to write it out in all of these steps. Again, this is a lot of steps that's being skipped in the middle here. Okay, we're jumping from 3 to 12. We're skipping 4, 5, 6 all the way up to 12. All right, so let's use that for this problem. So again, evaluate this one right here. Here's my rule. Okay, this is what I ultimately want to use. N over 2 times a sub 1 plus a sub n. So in this specific example, we know where we're starting at actually. We're starting at a sub 3 and we're ending at a sub 10. So we're starting here and we're going up to a sub 10. So instead of a sub 1, we're going to treat that a sub 3 as that idea. Excuse me. So in this case, with 2k plus 1, all I need to know is this term and this term. That's going to be able to fill in these two. Okay. The n is going to be a little bit different here. It's going to, let me bring that up in just a minute here. So, sorry about that. If I do this, if I do a sub 3, that's going to equal to 2 times 3 plus 1. That's 6 plus 1 is 7. A sub 10, I'm going to do the same idea. So 2 times 10 plus 1. So that's going to give me 20 plus 1 is 21. Okay, so I know these two values. Now, because I'm putting this into term, like normally it's a sub 1. Okay, and this is a sub n. This is going to be representing my a sub 1, which is technically 2 numbers beyond where we're at. Okay, so this is 2 numbers above this. So because of that, I'm going to treat this as my a sub 1. I'm taking 2 away, which means I'm taking 2 away from here. That's a sub 8. So in my sequence, this is the third term. If this is calling this my first term, this is actually my 8th term. So it's like 7 spots more than what it is. So my sequence is actually going to be made up of 8 terms total. So I'm going to have 8 over 2 times my first term, which is 7. Whoops. 7 plus the 21. Okay, again, this 8 is throwing us off a little bit because it almost looks like we should do 10. But since we're starting at 3, that's only 8 total terms. It's the 3rd, 4th, 5th, 6th, 7th, 8th, 9th, and 10th terms. That's 8 total terms in my sequence. Okay, so that means my sum of those 8 is going to be 4 times 7 plus 21 is going to be 28. So if I do that, that's 4 times 28. Gives me 112. Okay, so again, that's the sum of all the numbers starting at the 7. We're technically adding 2 every time until we get to 21, and all those numbers added up comes out to 112. Okay, and that is it for today. So feel free to pause it, try this one out, find the sum of these numbers, find the first 3 terms of this one, and let's use our sigma notation to find the sum of this series. Okay, so that's it for 10-2 day 2. Take care, everybody.